What if the algorithm we've been using to fine-tune language models with reinforcement learning has been fundamentally broken from the start? This paper reveals a hidden structural mismatch in how we've been applying trust regions to models with massive vocabularies. Building on that tension, let's examine exactly where things go wrong. The authors identify that PPO's ratio clipping creates a paradox in language model training. It simultaneously blocks useful updates to rare tokens, while missing catastrophic shifts in common ones, leading to widespread training failures that practitioners have struggled to explain. To fix this, the researchers needed to rebuild the theory from scratch. The paper establishes rigorous theoretical guarantees by generalizing classical trust region results to the language model setting. These bounds prove that monotonic improvement requires constraining the actual divergence between policies, providing the mathematical foundation for their new algorithm. Armed with this theory, they designed a practical algorithm. Divergence Proximal Policy Optimization replaces ratio clipping with a mask built directly from divergence estimates. This seemingly simple change eliminates the structural bias, allowing the algorithm to properly explore low-probability tokens while still preventing catastrophic policy shifts. Computing exact divergence over entire vocabularies would be prohibitively expensive. The authors introduced two clever approximations that preserve theoretical fidelity while remaining computationally tractable, with the binary variant proving especially efficient for deployment at scale. The experimental results validate the theory decisively. Across 5 large-scale experiments with modern architectures, DPPO consistently outperforms ratio-based baselines. Remarkably, the authors trace nearly all training instability to a tiny fraction of updates on negative samples, which DPPO's divergence mask precisely targets. Beyond immediate performance gains, DPPO fundamentally changes how we should think about trust regions in language model reinforcement learning. By properly handling the token-rich environment, it unlocks exploration pathways essential for aligning models with complex human preferences and reasoning requirements. The lesson is clear: applying classical algorithms to language models requires rethinking foundational assumptions about action spaces and trust regions. Visit emergentmind.com to explore how divergence-based methods are reshaping reinforcement learning for large language models.